Hello, Math 140 students. We are going to pick up on page 1, section 9.1, which is the square roots. A square root is written with a radical symbol, and the number or expression inside the radical symbol is called the radicand. All positive real numbers has two square roots, one positive square root and one negative square root. The positive root is sometimes referred to as the principal square root. So below are some of the common square roots. So all the square roots 1 through 15. So the square root of 1 is 1, the square root of 4 is 2, all the way up through the square root of 225 is 15. So if you need that as a reference, there you go. So what we want to do is we want to start simplifying some of these expressions. So let's take a look at number 1. We are going to go ahead and focus on each one individually. So I'm going to focus on the square root of 4. So notice here I have the square root of 4, which is going to give me 2. Plus, now I'm going to focus on the square root of 144. So the square root of 144 is 12. So now it comes down to adding 2 plus 12, which is going to give me a 14. So my final answer there is going to be a 14. Now, what's different for number 2 is that the square root is underneath, the square root, what we have underneath the square root is the 64 and the 225. So notice how in number 1 there is 2 different square roots. In number 2 there's only 1. That means I have to combine what's on the inside first. So this is going to be the square root, and now I have to add the inside numbers together. So I'm going to have 64 plus 225, which is going to give me 289. And now I want to figure out the square root of 289. So notice that we have that 15 is the square root of 225. So it needs to be bigger than that. So if I get my calculator, you can always use your calculator in this class. Remember, you want the square root of 289. So we're going to go ahead and plug this into your calculator. So I'm going to go second square root. Let's try that again. So second square root, and I have 289. Make sure you enter in the right number. So I have the square root of 289. Now that I have that in my calculator, I press enter and I get my answer as 17. So now I know that all of this is going to equal to 17. Now let's look at the next one, number 3. I have the square root of a negative 49. So notice that if I have a square root of 49, that's equal to 7. But what makes this difficult is that I have a negative on the inside. So if I have a negative inside the square root, well, let's take a look at that. If I were to plug in the square root of a negative 49, it gives me error, right? Non-real answer. So what that's telling me is that it's an imaginary number. So here we are going to say non-real solution. So you can either say that it's a non-real solution. Another thing that you can say is that you can just say no solution. I believe that's what it says on Newton, okay? Now, if you look at number 4, the negatives on the outside of the square root. So this is really saying that you have negative 1, and it's being multiplied by the square root of 49. Well, we already know that the square root of 49 is 7, and you have that negative 1 hanging out on the outside, and it's being multiplied, so you end up getting a negative 7 as your final answer. Now, sometimes the homework is going to ask you to estimate between two consecutive whole numbers. So you might want your calculator for this one. So we want to estimate the square root of 346. So if I have the square root of 346, I'm going to get that it's 18.6. So what two numbers is this 18.6 between? Well, it's between 18 and 9. So it's between 18 and 19. So if I have an 18.6, the number that it's between is 18 and 19. And if you want to just think about it, here is 18. Maybe this is an 18.5, and this is 19. So that 18.6 is about right here. So consecutive numbers, two consecutive whole numbers, that means one after the other. So a whole number would be 18, and my other whole number would be 19. So let's take a look at the square root of 51. So I'm going to have my square root of 51. Now I have that it's 7.14. So what two numbers is between? Well, on the lower half I have 7, and on the upper half I have 8. So I'm going to say it's 7 and 8. So the two consecutive whole numbers that the square root of 51 lies between is 7 and 8. Now the next thing that they're going to want us to do is to simplify these radicals. So here are the steps to simplify radicals. First of all, you want to identify the index. Then you want to rewrite the radicand to powers that can be divided by the index. Then we want to divide all factors that have powers divisible by the index, and then we want to rewrite the radical. So what does that mean in English? Well, let's look at the index, right? So we're going to have step number 1. So the index is that little number inside the square root. So notice that there isn't a number there. So when there isn't a number there, it defaults. It defaults to be a square root. So in this particular instance, we are going to say that the index is 2. So if the index is 2, we want to make sure to rewrite the radicand. So remember, the radicand, this is vocabulary, is everything underneath the square root. So that is the radicand. We want to make sure that that power can be divided by the index. So can 14 be divided by 2? Yes, it can. So we don't really need to rewrite it. That's sort of already done for us, okay? Because 14 can be divided by 2. This power can be divisible by that index of 2. So now we are going to divide it. So I have my n. I have my power of 14, then it's going to be divided by that index of 2. So now if I have 14 being divided by 2, I'm going to get 7. So now I have my answer as n to the 7th power. So n to the 7th will be my answer here. Now, let's look at number 2. So if I'm looking at number 2, remember our first step is to identify the index. So this index by default is a 2 if it's not listed. So I know that my index is 2. So I want to make sure that I can rewrite everything in the radicand that has powers that can be divided by the index. Okay, so I've identified the index. I'm going to rewrite everything. So the square root of 225. So I think I have that up here. Yep, here we go. The square root of 225 is 15. So I'm going to rewrite this so that 225, I really know that that's 15 squared. Okay. Now I'm going to take a look at that D value here, 52. Well, 52 can also be divided by 2. So I'm going to go ahead and let that be. So I have D to the 52. Now I know that everything in the radicand can be divided by my index, okay? So I have my 15 squared, and it's going to be divided by the index of 2. I also have my D to the 52 power, and it's going to be divided by the index of 2. So now what ends up happening, well, what's 2 divided by 2? That's 1. So I really have 15 to the 1 power. Now if I'm looking at my D, well, if I have 52 divided by 2, that's going to give me 26. So now I have 15 D 26 as my final answer. I have rewritten the radical. So I'm going to try to do the exact same thing for number 3. So I'm going to rewrite it, and remember our index is always a little number, and if it doesn't have a little number, it defaults to be a 2. So I know that I have an index of 2. So I want to make sure that all of the powers inside the radicand can be divisible by 2. It can be divided by 2. So I'm going to have this, and I still have my index of 2. Well, I know that 196 is really just a 14 being squared. And that's, you can look at that chart if you're confused at all. Now I'm going to look at my D value. Well, 32 is an even power. I know it can be divisible by 2. So D to the 32 power. And I have my N to the 28. And 28 is also an even number, so I know that it can be divided by 2 as well. So everything inside the radicand can be divided by 2. So now I'm going to have my 14 squared being divided by 2. Well, that just gives me 14. Now I'm going to look at my D32. That also gets divided by my index. So 32 divided by 2 gives me a 16. So I have a D to the 16 power. And now I have my N. So 28 being divided by 2. And that's going to give me a 14. So now I know that my final answer is 14, D, 16, N, 14. Okay. Now, 250. Well, if I were to do the square root of 250, let's think about this. The square root of 250. Notice how it's not a nice number. It's not like it's 14 or 15 or 16, right? It's 15.8113883. So it is a decimal. So what we want to do is we want to get an exact answer. So we are going to break down the number as much as possible. So we are going to do a prime factorization of the number. So prime factorization. So if I have the number 250, to break it down, I know I can say it's 25 times 10. which is 5 times 5, and 2 times 5. So I know that 250 is equal to 2 times 5 times 5 times 5. So now I can break down that 250 pretty nicely. I know that it's 2 times 5 times 5 times 5. Or better yet, I can say that this is 2 times, and remember, my index, if it doesn't say it explicitly, it's going to be a default of 2. So I really have a 5 squared. And the reason I'm going to group those two together is because of the index. Remember, that index is going to drive that power. So the only thing that can be taken out is that 5 squared. So on the inside, I still have that 2 times that 5, but now this 5 squared gets jumped out. And it's going to be divided by my index of 2. So now I have a 5 square root of 2 times 5, which would just give me 5, and then, well, what's 2 times 5? 2 times 5 is 10. So my final answer there is going to be 5 square root 10. So 5 square root 10 is my final answer. So let's go ahead and think about this for number 5. For number 5, I'm looking at that prime factorization of 45. So let's think about this. So if I have 45, that can break down as 5 times 9, which is 3 times 3. So 45 is equal to 3 times 3 times 5. So I really have 10 plus the square root, and 45, remember I said it's going to be broken down as 3 times 3 times 5. And my index, it defaults to be that number that you don't see, and it defaults to be a 2. So now I want to make sure to rewrite it as a power of 2 if possible, or something that's divisible by 2. So I have 10 plus the index. So now I have a 3 squared times 5. So now I know that this 3 squared is going to jump out right in front, but behind the addition sign. So I have 10 plus, and I have my 3 squared divided by my index, and what's left inside is that 5. So I'm left with 10 plus, and what is 2 divided by 2? It's 1. So you're left with a 3 square root 5. So my answer is 10 plus 3 square root 5 as my final answer. Now, let's take a look at number 6. So if I'm looking at number 6, what this is really saying is that I have 2 fractions. Even though it looks like 1, it's really a 2. And the reason I know that is because of this addition sign. Okay, so that means 20 divided by 2 plus the square root of 216 divided by 2. So I'm going to go ahead and rewrite it as such. So I really have 20 being divided by 2 plus the square root of 216 being divided by 2. Well, 20 divided by 2, you can go ahead and plug that into your calculator if you are confused. So that 20 divided by 2, in case you need to see it, is really 10. So I know that that is going to break down to 10. Okay. And I did that on my calculator. Now, what I really have to concentrate here is going to be that second part. So I really have to break down that square root of 216. So let's think about this. 216. Well, if I did 216, I know that that can be divided by 36. 36 times 6. And 36 is 6 times 6. So I have 6 times 6 times 6 is 216. So I'm going to rewrite that as the square root of 6 times 6 times 6, all being divided by 2. Now I'm going to group this because I have my index of 2. So I still have my 10, that hasn't gone anywhere. And now I'm going to group that 6 squared and divide it by my index so that I still have a square root of 6 on the inside, all being divided by 2. So again, that 10 just kind of comes along for the ride. And now that 6 squared divided by 2 just becomes a regular old 6. And on the inside, I have the square root of 6, and everything is being divided by 2. But now I can have 6 divided by 2. So I'm going to have 10 plus, and 6 divided by 2 is 3. And I still have my square root of 6. So my final answer is going to be 10 plus 3 square root 6. So that's kind of the game, right? Is try to rewrite the radicand as much as possible so that it has a power that's divisible by the index, and then simplify as much as possible. So looking at number 7, I have 125. So I'm going to go ahead and break that number down first. So over here, 125. Well, I know that 5 can go into it. So 5 times 25 gives me 125. But 25 can be broken down as 5 times 5. So I know that 125 is 5 times 5 times 5. And let's take a look at the index. This index here is really a 2. So I'm going to go ahead and group that and say that this is 5 squared times 5. Alright, so I'm going to have my square root. And the first thing that I'm going to break down is that 125, which I already did. And I said that's going to be 5 squared times 5. And we did that because my index is 2. The next thing I want to look at is that x to the 17. Well, can 17 be divided by 2 evenly? No, it's going to give me a decimal. So I'm going to rewrite the x so that it's divisible by 2. I'm going to say that this is going to be x to the 16 times x to the 1. Well, what's 16 plus 1? It gives me 17. So all I did was break it down so that one of the powers can be divided by the index. And the last thing I want to look at is my y. So same thing, 33 cannot be divided by 2 nicely. It's going to give me a decimal. So I'm going to say this is y, 32 times y to the 1. Because 32 plus 1 is 33. So now I know everything that's going to be jumping out, or that's going to be able to kind of break free, as you can say, because the power can be divided by the index. So this can jump out, this can jump out, and this can jump out. Everything else is going to remain. So let's think about this. So I have my 5 squared being divided by my index. So that's going to give me 5. Now I have an x. 16 divided by 2, well, 16 divided by 2 gives me 8. And the next thing I want to look at is my y. So if I think of my y, 32 being divided by 2, that's going to give me a 16. And what stayed on the inside, well, I had a 5 that stayed. I had an x that stayed. And I had a y that stayed. So that ends up becoming my final answer. 5x to the 8, y 16, square root 5xy. So let's keep chugging along at these problems. So now we're going to be dealing with division. So with the division, what's really nice about this is you can go ahead and split it out if you need to, or you can combine them. So that's kind of the cool thing about this. So the way I think about this is, well, if I look at the number first. I have 48 and 3. Can 48 be divided by 3? And if you don't know, you can always check your calculator. So let's see. 48. And I want to see if that can be divided by 3. Well, 48 divided by 3 is 16. Perfect. So I know that that's going to give me a 16 on the inside. Now let's look at our x value or our z values. So remember our rules of exponents. You are going to have z's that are going to cancel out. So let's just do it over to the side if you need to. So if I have z to the 7 and z to the 3. Well, that looks like 1, 2, 3, 4, 5, 6, 7 z's on top and 1, 2, 3 z's on the bottom. So these cancel, cancel, cancel. So you're left with 4 z's up on top. So I have z to the 4. Another way you could have done this is if I have z to the 7 over z to the 3, you could have done z to the 7 minus 3, which gives you z to the 4th power. Just a little reminder there about our rules of exponents. And don't forget, we have the index of 2. So what is the square root of 16? Well, the square root of 16 is 4. And I have z to the 4. So what is this power being divided by this index? Well, 4 divided by 2 gives me 2. So my answer here is 4z squared. Okay. Now for number 9. I have 169 divided by 196. So let's see what that looks like. So 169 being divided by 196. So when I do that, I don't get anything that's really nice. So let's see if I were to split it up. What if I had instead the square root of 169 over the square root of 196? Now I can deal with the numerator and the denominator separately. So up in the numerator, I am going to have the square root of 169, which is 13. And in my denominator, I'm going to have the square root of 196, which is 14. So my answer here is 13 over 14. That will be my final answer. All right, so now let's look at number 10. So we have a lot going on with number 10. So the first thing we want to do is try to simplify this as much as possible. So let's take a look here. Well, I have 384 and 242. So what I could do is I can just leave those numbers alone for now. So that 384 and that 242, I'm going to deal with the numbers separately later. But what I really want to do here is look at my u's. If I look at my u's, I have u to the 5 on top and u to the squared on the bottom. Well, which one's bigger? The 5 is. And where is it located? On top. So I have u, and now I'm going to subtract 5 minus 2 is 3. So that took care of my u's. Now I want to take care of my v's. So remember, this v has an exponent of 1 by default if nothing is there. So which one is bigger? The one on top or the one on the bottom? So is 1 bigger or 13 is bigger? 13 is bigger, and it lives on the bottom. So I have v, now I'm going to subtract. 13 minus 1 gives me 12. Okay. And let's see, do I have anything nice like the square root of 384? I can. So let's think about this. So I'm going to go ahead and give myself some more room here. All right. So I have 384 being divided by 242, and that does not give me anything nice. So I'm going to split it. I'm going to say that it's two different fractions. So in my numerator, I'm going to have the square root of 384u to the third power. And down at the bottom, I'm going to have the square root of 242 and v to the 12th power. So that's going to make my life a little bit nicer. So I'm going to deal with each one separately. So on my calculator, if I have the square root of 384, you can either plug this into your calculator directly, or you can just break it down. So if I have 384, I know that I can have 64 in there. So let's see, 384 divided by 64, that's going to give me a 6. And 64 is really just 8 times 8. So I have 8 squared times 6. So in my numerator, I'm going to rewrite that as an 8 squared times 6. And remember, I'm writing all this so it can be divisible by 2 because my index is 2. And I have a u squared u1. Now I'm going to look at my denominator. If I'm looking at my denominator, I have 242. Well, I know that that can be broken down as 121 divided by 2. And 121 is 11 times 11. So I can rewrite this as 11 squared times 2. Perfect. So now I have 11 squared times 2 times v to the 12th power. And remember, I have an index of 2 for both of them. So when it's not there, it defaults to be a 2. So now I know everything that's going to cancel out or jump out. I have an 8 squared and a u squared. So 8 squared, and I divide that by a 2, that gives me just an 8 on the outside. And I have a u squared being divided by 2, so that gives me just a u. So what stays on the inside is a 6u. Now, in my denominator, I know that my 11 squared and my v12 get to kind of jump out. So I'm going to have 11, and 12 divided by 2 is going to give me 6. So v to the 6th power. And I have my square root, and I have a 2 left on the inside. And nothing else can cancel out. So that's going to be my final answer. Now, something else that we are going to be able to do is to evaluate a radical function. So what we want to do is we have this function and we want to plug in this value. So this is telling us plug m is equal to -4 into my equation. So this m is going to have this value. So okay, I'm going to have the square root of a -14 parentheses plus 8. And that value that I'm plugging in for m, remember, is a -4. So as I plug that into my calculator, I'm going to have a -14 times a -4, and I have a plus 8. That's going to give me 64. Well, we know that the square root of 64 is just 8. So I'm going to have that s of -4 is equal to a positive 8. That's going to be my final answer. So let's see if we can do that again for number 2. It's the same process. So now we have my function h, and what I'm plugging in for my d value is this -5. So here, plug d is equal to a -5 into this equation. So I'm going to have, and notice my index here is 4, so that's a little bit different. Now I'm working with a 4th index. So I have a -2 parentheses -9. What I'm plugging into that parentheses is that -5. So I'm going to have -2 times a -5 minus 9, and I can use my calculator for this. So this is going to equal to the 4th root of 1. Well, if I have any root of 1, doesn't matter it's 4 or 5 or 10 or 100, 1 times 1 is always going to equal to 1. So 1 times 1 times 1 times 1 is going to give me 1. So my final answer, you say h of -5 is equal to a positive 1. And that's going to be my final answer. Okay, now the next thing we want to think about for section 9.1 is the domain of a radical function. So remember that the domain is always going to be an interval notation. So that interval notation, we've done that before. Remember, it goes from our smallest number to our biggest number. So we can either have parentheses, or we can have brackets, or we can have a combination of parentheses and brackets, or brackets and parentheses. And it always goes from the smallest number to the biggest number whenever we are dealing with our interval notation. Okay, so the thing that's kind of tricky about this, not tricky, but an interesting thing here, is that if the index is an odd power, the radicand can be any real number. So if it's an odd power, it's always going to be -infinity to infinity. So let's think about this. It's asking us for the domain, so let's look at the index. Well, here, my index is 7, which is odd. Oh, so since it's odd, it defaults that I'm going to have -infinity to +infinity. okay? And it's only because the index was odd that I'm able to do that. Now, let's think about number 2. Well, what's this index here? Well, it defaults to be a 2. So I have my index of 2, which is even. So it's not odd. Okay, so that means we just have to set the inside greater than or equal to 0. So remember, the inside of the radical can never be 0 or can never be negative. That's where we got the error. So I'm going to say negative 10z minus 5. And it has to be, not equal to 0, but it has to be greater than or equal to 0. So I'm going to go ahead and add 5 to both sides so that I have a negative 10z greater than or equal to a positive 5. Now I'm going to divide by a negative 10 on both sides. So I'm going to have z, and if I have the division, so I have a fraction, 5 being divided by a negative 10, that's going to give me a negative 1/2. Remember, whenever you divide or multiply by a negative, the inequality changes direction. So now z is less than or equal to a negative 1/2. So if you want to think about this on the number line, here's 0, here's a negative 1/2. So I have a closed filled-in circle because it's less than or equal to, there's a line underneath it, and it's everything less than. So my interval notation is going to go from negative infinity to a negative 1/2 bracket. And that is going to be my final answer. And that's the end of section 9.1. If you guys have any questions, please make an appointment with the Math Success Center or with your instructor. Thank you.